This lesson is on one-step equation. So before we go ahead and do that, let's go ahead and talk about the parts that we're going to use to model our equation. So the first part is going to be the yellow square that's going to represent the number. And yellow is going to represent positive. So if it's a negative number, you're going to have is a red square instead. The second one is going to be an X bar. That's going to be, again, green is positive, red will be a negative x. And the third one we have is x squared, which will be a larger square, and that's going to be a blue square to represent the positive. If it's negative, it's going to be a red x squared. Okay, so we're going to use those three parts to do our modeling of our equation. So for x plus 2 equals 4, we modeled it with the green right here as being the x right here. The positive 2 is represented by the yellow right here. The equal sign, I put 2 bars right here to represent the equal sign. And then positive 4 is on this side right here, being yellow because it's positive. Now the rule is whatever cross over the equal sign, whether it goes to the right or goes to the left, it will have to change the sign from positive to negative and from negative to positive. So what we want to do is have x by itself. So we have to bring this right here over to the other side of the equal sign. So if we bring it over to the other side of the equal sign, I'm going to bring 1, 2, both of those are going to come to the other side of the equal sign, and because they crossed over the equal sign, they're going to have to change sign from positive to negative. And we have also learned that if you have one positive, one negative, it becomes 0. So the first 2 boxes right there, they're going to become 0 because we have a positive and a negative right here and a positive and a negative right here. So then you're left with is just x is equal to 2 because I still have this x right here. This is an equal sign right here, and this is 2 right here. Okay, let's try another example. We have as x plus 4 equals negative 3. So again, the x represents right here the model for that. Plus 4 is positive 4 right here. Equals right there. This is equals. And then minus 3 is going to be this part right here, the negative 3. So now let's go ahead and bring our yellow or the positive 4 over to the other side of the equal sign. So if we bring those over right here, when they cross over the equal sign, they're going to change signs from positive to negative. And so now you have is x equals negative 7 as your final answer. The next example is x minus 3 equals negative 7. So now we have to bring our minus 3 over to the other side of the equal sign. So let's go ahead and bring it over. And when they cross over the equal sign, they now become positive in this case because they were negative before. And again, when we have a positive and a negative, they become zeros. So now those disappear, and you're left with is x equals negative 4. Now let's try the 2x is equal to negative 6. So what we have is 2x instead of 1x. Notice that the previous problems all have 1x. Our goal is to have 1x. If you do not have 1x, you're going to have to find a way to get 1x. So to get 1x for this, notice that I have this part right here is 1 and 2, and I also have is negative 6. So what you need to do is now take all of this negative 6 and divide it into 2 parts, so each one of these x's will have a group of numbers. So let's go ahead and divide them up. So I'm going to go ahead and sort it out where I bring one up here and I bring one down here. So now each of the x's right here has a group of numbers right there, right? And it has to be equal number as well. So in our case, this answer becomes x is equal to negative 3 because each of the x's have a group of negative 3. Okay, let's try another example. I have as 4x equals 4. So again, each of the x's need to have something. So I'm going to go ahead and flip this right here so that way it's easier to see them matched up. And we're going to take the positive 4 on the right hand side and group them to each of the x's right there. So you can then see that each of the x has something, and that something is equal to 1. Okay, now let's try another one. I have is now x divided by 2 is equal to 4. So this is a little tricky. What happens is then our green bar normally is this, all of this is the green bar. But in this equation right here, I have as x is equal to half. That means in our x bar that right now that we have, only half of it is showing. And in that half right there that is showing right here, that is equal to 4 of that. So I need to double this right here, right? So that I can get both of these bars. And so then all of this becomes 1x right here. Now in algebra, whatever you do on one side of the equal sign, you also have to do on the other side of the equal sign. So if I double it on the left hand, I also have to double it on the right hand. So when we double on the left hand, the doubling of the right hand becomes that. So our final answer is x is equal to 8, because now this looks like a regular x bar right here, and because we doubled that part right there, now we're going to have is 8 total right there. Okay, last one we have is x divided by 3 is equal to 2. So again, normally this would be a regular x bar right here, but because I cut it in thirds, right, third part of it, only 1/3 is equal to 2 right there. So to get all of this right here, I'm going to have to multiply by 3 so I can get all of that. And so if I multiply 3 on that side of the equal sign, I also have to multiply 3 on the right hand of the equal sign. So let's go ahead and show it. So then if I double this part right here, right, that's times 2, that's going to be doubled right there. If I times it by 3, now we're going to have this part, the third part. So our final answer is now x is equal to 6. That is how you solve for one-step equation.